Welcome friends. Today we shall discuss the topic of current and electricity. At first we discuss some basic definitions from this chapter. Then gradually we go resistance, equivalent resistance and so on. So this chapter is about current and electricity of class 12. This chapter is about current and electricity of class 12. Now we can show that why current flows through a conductor. If we take a conductor of uniform cross section A and length of uniform cross section A and length L and uniform cross sectional area A, then what is the cause of flowing current through this conductor? Are you know? When there is no electric field applied in the conductor, that is the potential difference not applied between the two ends of a conductor, this ends and this ends. If there is no electric field is applied, no power source is given, then the any place of the conductor, the net charge flowing through this direction through this cross section is equal to the net charge flowing through this cross section in opposite direction. If n number of electrons and charge of each electron is n e, then any charge is n into e charge is goes through this and n into e charge passing through the opposite direction. Therefore, in any cross section of this conductor, the net charge or net velocity of electron is 0. If there are n number of particles and n number of particles means say electron, and u1, u2, u3, un be the u3, u4 and un be the velocity of each particle, and there are such n number of carriers. Therefore, the average velocity, that is u bar, is equal to u1 plus u2 plus u3 plus un divided by n equal to 0. So, when there is no drifting of electrons occur, that means no electric field is built up inside the conductor, the net charge inside a conductor is 0, because the charge particles, say electrons, are randomly moved in any direction. So, the net charge will be 0. Now, let us say drift velocity. What is drift velocity? Drift velocity, or what is drifting of electron means? When a battery is connected across the conductor in such a manner, plus minus, this is plus terminal, this is minus terminal, then a current is built up inside the conductor, because the electrons are moving from negative terminals to positive terminals, and an electric field is built up from positive to negative terminals along this direction, just opposite the direction of electrons. As electrons moves from negative to positive, an electric field is built from positive to negative terminals. and also the velocity and accelerations are along this direction opposite to the electric field. Therefore, a net current is introduced along opposite motion of electron, that is along the electric field along this direction, positive to negative. So, when a battery is connected across a conductor, the current built and current goes through this conductor opposite to the electron, that is along the applied electric field. Now we can introduce the drift velocity of electrons. We know that electric field E equal to V divided by L. The electric field inside a conductor is equal to potential difference divided by length of the conductor if the conductor length is L. Now, what is E? Electric field equal to force upon charge FQ. E equal to QF, Q, F equal to Q times E. F equal to Q times E. Therefore, if this is the electron, then Q equal to minus E minus small e plus the force on electron. Therefore, acceleration A equal to F divided by m equal to minus E divided by m. If we put E equal to V by L, what can we get? Minus E V by m L. Now, this is the acceleration of electron inside the conductor. Now, what is the final velocity of electrons? V1 for 1 electrons, U1 plus A T1. T1 is the relaxation time. What is relaxation time? Inside the conductor, electrons collide with each other and also with the ions, with positive ions present in the conductor. That is, T1 is the time interval between two successive collisions. When the electrons collides an positive ion and it collides another positive ion, the time interval between the two collisions is the relaxation time T1. Therefore, for any electron V1, the final velocity is U1 plus A T1. Similarly, for V2, U2 plus A T2 and so on. Therefore, what can we get? We can get, if we add this V1, V2 and Vn, what we can get? If we add this, V1 plus V2 plus V3 and Vn, we can get U1 plus U2 plus Un plus, if we common A, we can get T1 plus T2 plus Tn. If we divided the whole equation by total number of electrons, that is, if n number of electrons present, then we divided this n and also we divided this n. Therefore, V1 plus V2 plus Vn divided by n is the Vd, drift velocity, equal to, we can prove earlier that U1 plus U2 plus Un by n, the velocity when no electric field is applied equal to 0, average velocity equal to 0. So, in this case this is 0 and A, this is tau n, this is tau n, average relaxation time. Therefore, Vd is equal to A tau n. Vd equal to A tau n. What is the value of A? From this, we can put the value of A, that is Vd is equal to A, the value of A is minus EV by ml tau n. In terms of electric field, the value of A is EE by m. In terms of electric field, the EE divided by m tau n. This is the equation for drift velocity inside a conductor. Equation for drift velocity inside a conductor is given by Vd equal to minus EE by m tau n or minus EV by ml into tau n, where E is the electron charge 1.6 into 10 to the power minus 19 coulomb, V is the potential difference, m is mass of electron, L is the length of conductor, and tau is the average relaxation time, that is the time interval between two successive collisions. Now, drift velocity may be defined as the velocity, the average velocity of electron inside the conductor. Therefore, what is drift velocity? Now, the drift velocity is the average velocity of electrons inside the conductor under influence of electric field. We say it again. What is drift velocity? What is drift velocity? Now, drift velocity is the average velocity of electron inside a conductor under influence of electric field. Average velocity of electrons inside the conductor under influence of electric field is the drift, is known as drift velocity. Let us do a math using these equations. A conductor, there is a conductor of length 8 meter. The conductor has length 8 meter and applied a potential difference V is equal to 6 volt across it. If the drift velocity of free electron is, if the drift velocity, that is Vd, of free electron is 2 millimeter per second, 0.2 millimeter per second, 0.2 millimeter per second, then find the average relaxation time, that is tau n, average relaxation time of the free electrons. What can we get? What can we get? So, the given value is L, L is given, the length of the conductor is 8 meter, a potential difference 6 volt is applied, the average velocity of electrons 0.2 millimeter per second. Therefore, 0.2 into 10 to the power minus 3 meter per second. And what is tau n? So, from this equation, from the equation 1, we can get Vd, the equation is Vd equal to E, we can neglect the negative sign, E V divided by ml tau n. Then what is tau n? Tau n equal to, what is the value of tau n? Vd ml, Vd ml by EV, Vd ml by EV. If we put the value of the given physical quantity, Vd equal to 0.2 into 10 to the power minus 3, value of m is mass of electron. What is the mass of electron? 9.31 into 10 to the power minus 31 kg. 9.31 10 to the power minus 31 kg. And what is L? L is given 8. What is E? 1.6 upon 10 to the power minus 19 coulomb. And what is V? The potential difference is 6 volt. Therefore, this is second. If we calculate this, if we take 9.31 or 9, the value will be same. Therefore, we get, if we calculate this, 1.5 into 10 to the power minus 15 second. You can easily solve the numericals using calculator. So, there into 1.5 into 10 to the power minus 15 second. This is the relaxation times. Generally, the relaxation time is very small, of the order of 10 to the power minus 15. And the charge of electron is also small, minus 19. Then what can we get? Large number of current, large value of current inside a conductor, because there are very large number of carriers, that is electron, inside a small volume of conductor. So, we get generally large current. Next, we can show the relationship between electric current and dip velocity. The relationship between electric current and dip velocity. Electric current and drift velocity. Again, let us consider a conductor of uniform cross section area A, length L. Uniform cross section area A, length L, and n be the, small n be the number of electrons per unit volume, that is number charge, number density of electrons, number of electrons per unit volume. If A and L, therefore, number of electrons in L, length L, total number of free electrons, total number of free electrons, total number of free electrons, capital N is equal to NaL. Understand or not? N number of electrons per unit volume. What is the volume of the conductor? Cross sectional area into length. Therefore, in per unit volume there are n number of electrons. N is number of electrons unit volume. Therefore, in AL volume the total electrons NaL. If E be the charge of one electron, therefore total charge equal to E multiplied by NaL, that is NeAl. This is the total charge. Now, what is the time t to move an electron through this length L? This is the length upon drift velocity V, S equal to Vt equation, L by Vd. Then what is the current I? Current means dq dt, or simply charge upon time. The amount of charge flowing per unit time is called charge. So, I equal to dq dt. What is the value of q? Total charge q equal to NeAl. We put the value of NeAl and divided by Vd. Sorry, divided by T. T means L by Vd. L divided by Vd. Therefore, NeA, LL cancel, NeA Vd. NeA Vd. NeA Vd. Therefore, current I equal to NeA Vd. This is the relation I equal to NeA Vd. This is the relation between current and drift velocity. I equal to NeA Vd. That is, generally I is proportional to Vd. If the drift velocity will be greater, then the magnitude of current will be greater. Now, what will be the total current? What will be the total current inside a semiconductor or a conductor having different charge carriers? There will be total current, that is, if there is a conductor in which there are lots of charge carrier Q1, Q2, Q3, and the density of Q1 is N1, density of Q2 is N2, density of Q3 is N3, and the drift velocity will be V1, V2, V3, and drift velocity is V1, velocity is V2, velocity is V3, then the total current I is just common take A outside, Q1 A1 V1, Q1 N1 V1 plus Q2 N2 V2 plus Q3 N3 V3 and so on, Qn Nn Vn. That is the effect of, that is the like principle of superpositions. If a semiconductor, this will be seen in semiconductor. In semiconductor, there are two types of charge carriers. One is holes, that is the positive direction of charge carrier, positive value of charge carriers, and one is electrons. One is holes and one is electron. But the holes and electrons are maybe the density will be different, velocity may be different, but their charge will be equal. If the charge of hole and the charge of electrons will be always equal, but in negative signs. Hole is positive charged and electron is negative charge. Next, we can show what is mobility and current density. What is mobility and current density? Mobility is mu equal to mod of Vd divided by E. That is, mobility is the magnitude of drift velocity per unit electric field. Magnitude of drift velocity per unit electric field is called mobility. we can know what is the value of unit of mu in SI system. VD, value of VD is meter per second, and E is, what is the value of E? Coulomb per second. What is the value of E? E is volt. What is the value of E? E is volt meter. E is volt per meter. Then meter per second and volt per meter, that is meter square per volt second. Meter square per volt second. It is always positive. Mobility is always positive, and we can get magnitude of Vd. Meter per second is the velocity, and unit of E is volt per meter. So this m is in take up in upright. So we can get meter square per volt second is the unit of mobility in SI system. Now what is the value of Vd? Vd is E by m tau n. E by m tau n. Therefore, mobility mu equal to mod of Vd by E, that is E by m tau n. E by m tau n. This is the expression of mu or mobility. This is the expression of mu or mobility. Next, we can go with current density. Current density J. J is the current density. J is current divided by area. Current divided by area is called current density J. We can get earlier I equal to NEA VD. Therefore, J equal to I by A, that is NE VD. So, in this class we can get the different expression for 4 main terms and their equations. What is them? So, we can get if we take it in a summary form, we can get that drift velocity Vd equal to E by m tau n or E v by ml tau n, number 1. Number 2, we can get the value of I, current, with drift velocity NEA VD. Number 3, we can get the value of NEA VD. Number 3, we can get the value of mu equal to Vd by E is equal to E by m tau n. E by m tau n, and obviously for J equal to I by A, we can get NEVD. We can get these 4 important equations from this chapter. Suppose in hydrogen orbit, in hydrogen atom, an electron is revolving around it. The radius of atom is of the order of 10 to the power minus 5 meter or 10 to the power minus 11 meter. 5 into 10 to the power minus 11 meter. Sorry, 5 into 10 to the power minus 11 meter. The radius of hydrogen atom. Now, we can have to solve, find the equivalent current. Find the equivalent current. if an electron is revolving around a hydrogen atom in first orbit with a velocity 2 into 10 to the power 6 meter per second. The question is, in hydrogen atom an electron moves in an orbit of radius 5 into 10 to the power 11 meter with a velocity 2 into 10 to the power 6 meter per second. Then what current will be introduced in it? Now, how we can derive it? Now, as electron is revolving, that we can get Q equal to E equal to 1.6, neglecting the minus sign, 1.6 10 to the power minus 19 Coulomb. Now, what is the T, time of revolution? T is total distance revolving one complete cycle. The distance is 2 pi r and the time is 2 pi r upon V, that is 2 into 3.14, taking the value of pi, r equal to 5 into 10 to the power minus 11 divided by V. What is V? 2 into 10 to the power 6. This is the value of T. Then I equal to, we can know I equal to total charge upon time. That is total charge here is Q divided by this, E equal to 1.6 into 10 to the power minus 19 divided by this term. This term means 2 into 3.14 into 5 into 10 to the power minus 11 divided by this term 2 into 10 to the power 6. Now, this term will be get upward as we divided it, therefore, this is 2 into 10 to the power 6 the ampere. Therefore, if we substitute it, we can get 1.12 into, we can get 1.12 into 10 to the power minus 3 ampere, that is 1.12 milliampere. So, we can solve it that if an electron is revolving in an orbit of radius r, the current introduced with a velocity 2 into 10 to the power 6 meter per second, the current introduced is 1.12 milliampere. In this type, we can solve very numericals in easiest way by introducing these equations. Next day, we can go with another topics, resistance or some numericals by this problem. Hope you understand the class very well. Thank you.